Good morning. All right, we're going to do a couple things today. We're going to work on simplifying more radical expressions when it's not, when you got exponents under the radical. And then I'm going to go into multiplying using distributive property, as well as dividing fractions. So we're going to do a lot in this video. So first things first, very basic. We know that the square root of 16 is equal to 4 because essentially you know that 4 squared is 16, but the square root of 4 squared equals 4. Essentially what you're doing, because we learned this last week, this is also called the second root. What you're essentially doing is you're taking this, dividing it by this to get the answer of 4, all right, to the power of 1. This is really to the power of 1 to the power of 1. Now over here we have a new one that we haven't seen before. This says 25x squared. So I tried to help you guys see that so you guys can uncover what this is. Well, we know that square root of 25 is 5, and I know that there is x squared comes out as x. Every single time we're doing this with the second root, it's always the squared term comes outside as just the term. The squared term comes outside as just the term, 4. Just like here, the squared term comes outside as just 1x. Now over here, now it gets a little more complicated. I got 49x to the 4th, y to the 2nd. So now here's how you can think about this, if you guys would like, okay? We already know the square root of 49 is 7. Well, the square root of x to the 4th, well, think about this. X to the 4th is really x squared times x squared. And we'll dive into this later, but just to, be forthright in what we're doing, x squared times x squared is x to the 4th. When you're multiplying these, you always add the exponents. We're going to dive into this real deep at a later point in this unit. Remember, it's like saying the same as 2 squared times 2 squared. Well, that's 16. That's the same as 2 to the 4th power. 2 times 2 is 4, times 2 is 8, times 2 is 16. Just to make this make sense for you. So there are 2 x squareds, right? So one of these comes outside as x. The other one also comes outside as x. You have to multiply these both outside, so x times x is x squared. Or another way to think about it is, remember, this is always the second root. You just do this power divided by this root. 4 divided by 2 is 2. Just like here, 2 divided by 2 is 1. There's an invisible 1 above this. So there's 2 divided by 2 is 1. Same thing, I hope you're seeing the pattern on this. And then y squared comes outside as just y, just like that. Let's keep going. I got a couple more with some odd exponents, and you'll see this. Please pause if you need to. Now we got another one. We got 9x to the 3rd, y to the 5th. All right. I purposely chose odd exponents here, and you'll see why. First things first, we know this number, square root of 9, comes outside as a 3. Well, x to the 3rd is the same as saying x squared times x. Just like y to the 5th is the same as saying y squared times y squared times y. 2 plus 1 is 3. We never write the exponent of 1 above there, ever. All right? 2 plus 1 is 3. 2 plus 2 plus 1 is 5. We're all good right there. This x squared comes outside as just a x. So this is just x. Now, you're going to see what's going to happen here in a minute because this is not going to be a perfect square. All right, you're going to see 1 second. This comes outside as an x. So now this is on the outside, right? This x will stay inside. You'll see how that looks in 1 minute. This y squared comes outside as a y, just like this y squared also comes outside as a y. I'm going to multiply these together and I'm going to get y squared. Well, look at it in circle. Look what's staying inside because this is not a perfect square, nor is this. So now that that's not a perfect square, these guys just stay inside, and this simplifies to this, okay? Right down here, next one. Square root of 48, x to the 6th, y to the 3rd. Last week and a little bit of yesterday, we were talking about how it's so essential that you guys always divide by the biggest square root factor to make your life easier. This cannot be more true than right now. So if this is 48, I know this breaks down into a 16 and a 3, okay? X to the 6 is an even power, so if we're using my quick method, we know that 6 divided by 2 is 3, so we can just go right over there. So I know that 16 comes outside as a 4, this x to the 6, 6 divided by 2 is 3. And there's, remember, if you want to draw this out every time, be my guest. I know this is y to the second times y. 2 plus 1 is 3. This y comes outside as a y. And we are left over with this guy and this guy. So this is just going to be 3y. I'll have more examples in class for you guys today, but that's pretty much the gist of this. All right? Pause if you need to rewatch, but this is how it's going to be. Give me 1 second. All right. I'm going to do a couple more. These are just distributive property, more multiplying stuff we've done in the past, but now we're going to go one step further and use distributive property and be smart about all the moving pieces here. So I'll go one by one, okay? So we got radical 3 times radical 6 minus radical 3. Well, distributive property, this times this, this times this. So now this is just radical 18. Radical 3 times 8, remember this is minus. Radical 3, this is going to be 3. This breaks down, don't forget to break it down. We got a 9 and a 2 in here. This comes outside as a 3. So I got 3 radical 2 minus 3. We are all done because there are no more like terms there, so I can't simplify that any further. There's that. Pause if you need some. Number 2 says radical 2 times 2 radical 3 plus radical 6. And again, just distributive property. You might remember, there's an invisible 1 right here. So this invisible 1 times this 2 is 2 times, and we got a radical 6. Remember, not radical 5, you're multiplying. You can always multiply. I can do radical 2 times radical 6. That's a plus radical 12. This 12 breaks down into a 4 and a 3. So our final answer is going to be 2 radical 6 plus 2 radical 3. And because there is nothing else we can do because they're not the same radicals, we are all done with number 2. Let's do number 3 right beneath it. So I got radical 5 times 6 plus radical 15. And here we go. We got 5 and 6. I got 6 radical 5. Remember, this is not inside the radical. This is considered outside, so it stays outside. And this is just this. And 15 times 5, 575. Ooh, this is a nice one. So plus radical 75. And my radical 75 has a 25 and a 3. So, because we know this, break it down. We got 6 radical 5. This comes outside as a 5 plus 5 radical 3. And that's how you do something like number 3. Like number 4 right now, and then move on to the next one. So I got 3 radical 2 times 4 radical 6 minus radical 3. Again, outside times outside, 12 radical 12. Inside times inside, minus radical 6. Oops, I made a mistake. Good teachers make mistakes on purpose, but I was auditioning for that and I forgot that you guys were not in front of me right now. So 3 radical 6. Now I got to go one step further. I got a 4 and a 3 inside here. 4 comes outside as a 2. I multiply that by that number in front right there. So I'm going to get 24 radical 3 minus 3 radical 6. These do not have the same number under the radical, therefore we are all done. Back in a minute with some more. Alright, last but not least, we're going to work on simplifying radicals in fraction form. So I'm going to start easy and then get progressively harder, so pay attention. So here we go. We did this last week on a very surface level, but very basic. We know that the square root of this fraction is the same as saying for number 1, square root of 16 over square root of 25. And these are perfect squares, so this simplifies down to 4/5. Very basic. Number 2, a little different. I got square root of 5 over square root of 9. And remember, the only one golden rule is you can never have a radical in the denominator, ever. So the nice thing is I got a perfect square, so your final answer here is radical 5 over 3. And we are all done. Number 3 is, now you can do this one of 2 ways. I know that 8/12 reduces, okay? You can reduce 8/12 right away. to make your life a little easier. This says the same as divide 4 out of top and bottom, and I got 2/3. That's how that reduces. You can do it like that, or you can do it the long way. I'll do it both ways and I'll let you guys determine. Alright, so we'll do these side by side so you'll see with the same answer. But again, I always urge you guys to work smarter, not harder. If you can reduce the fraction, by all means, please do. Okay, because they're under the radical. So let's do it the long way. Okay, so number 3. So this is going to be, if I'm doing it the long way, I'm going to do radical 8 over radical 12. Now, my only rule is I can't have a radical in the denominator, so I'm going to multiply radical 12 out on top and bottom. And if I do that, I get radical 96 over, well, radical 12 times radical 12 is just 12. But radical 96 does reduce. Now, radical 96, I believe has a 16 inside of it, remember correctly, so let's see real quick. So let's do 96 divided by 16. Yep, it does. Got a 16 and a 6. Okay? So now this simplifies. The 16 comes out as a 4. So I got 4 radical 6 all over 12. But I'm not done because 4 over 12 does reduce. I can reduce these because these are both on the outside of the radical. So your final answer is essentially 1 radical 6, or just radical 6 over 3. Now a common mistake kids make is that they're going to do 6 divided by 3 and just say, oh, the answer is radical 2. Not the case. These are not like terms because this guy's under the radical, this guy isn't. Now let's see if I would have done it the way that I started. Alright, so that's the same as radical 2 over 3, so that's the same as radical 2 over radical 3. Now just multiply out the radical 3 on top and bottom to get rid of that radical in the denominator, because now I got radical 6 all over, well, radical 3 times radical 3 is radical 9, which equals 3. Okay, sweetie, one second. So that's how you do that one. 2 ways to do number 3. Okay? Going on to numbers 4 and 5. Number 4 says radical 3 over radical 5. So radical 3 over radical 5. Remember the rule, you cannot have a radical in the denominator. So I multiply that guy out at both top and bottom. So I'm left with radical 15 over 5. And we are done for number 4. Number 5 is already in radical form, so let's just do the work. Radical 2 over 2 radical 3. You cannot have a radical in the denominator, so literally all you got to do is multiply only the radical out. Okay? Multiply by radical 3. Multiply by radical 3. So now remember I have a 2 on top. Let's do top first. I'm going to have a radical 6 on top, and I'm going to have a 2 times, well, radical 3 times radical 3 is 3. So your final answer is going to be radical 6 all over 6. We are done for something like that. And then number 6 will get interesting. So let's do that one right beneath it, I think. We'll have enough room there. So we're going to have 12 radical 6 all over radical 2. Remember the rule, you cannot have a radical in the denominator. So there's that. So I multiply that out on top and bottom. I'm left with this 12 stays outside. Under the radical is just 12 all over. Well, radical 2 times radical 2 is 2. Now I can right away simplify this if I want, which is not a bad idea. 12 over 2 reduces to 6 over 1, or just 6 radical 12. But don't forget, radical 12 still has a 4 and a 3 inside of it. So this guy comes outside as a 2. So your final answer is 2 times 6, which is 12 radical 3. This should help you guys get through today's stuff we're doing, and we'll dive deeper into it tomorrow. See you guys in class.